Standard 7, Subject Science, Lesson number 18, Sound on Production of Sound, Part 1. A nature has given 5 sensory organs to a human body. Okay, which are those? Eyes, ears, nose, tongue, skin. Correct? So, out of that, ears are the organs by which we all are able to hear and recognize the different kinds of sounds they are produced. Some events are given below on the screen. You just along as I read the question, try to give the answer for that questions, that if you have experienced the event, whatever event I will read, have you experienced or not? If yes, then you will say yes, and if you have not experienced, you will say no. Okay. For example, first I will explain. Clapped your hands together. Have you ever clapped your hands together? Yes. Have you done the clapping? Yes, always. So you will give the answer for that is yes. So same way I will read on the question. Try to give the answer in your mind itself, whether it is yes or no. Second is played a musical instrument. Any musical instrument have you ever played? If answer is yes, then try to listen, try to memorize the sound of that instrument whichever you played. Burst of a firecracker. I think all of you must have experienced this one, that is bursting a firecracker in Diwali. Okay, it's obviously everybody of you must have heard the sounds which are produced by firecracker. Knocked on a closed door. Okay, have you ever experienced this? Yes or no? Okay. Whistled using the cap of a pen. Yes, I think it's your very favorite game. Okay, now holding the cap of pen in your near your mouth and whistle using that one. Then placed your palm on a mobile that is ringing. Okay, now also you are watching, most of you are watching this video on mobile phone. So I know that all of you must have observed, must have experienced how the mobile phone vibrates or it rings. Whenever it rings, you can feel the vibrations of the mobile. Okay, if it is on vibration mode, then how it feels. If it is on a sound mode, then how you feel. Then swung the clapper of the bell and the bell rang. Okay, either you visit any religious place, you must have seen the bell and you must have swung the clapper of the bell. Okay, and it mostly whenever you are a small, it's like every child's hobby to swung the clapper of the bell. Okay, whenever you visit any temple, you have to swung the clapper of the bell, and you like to hear the sound of the bell. Next is a metal utensil fell down with a clatter. Okay, sometime it happens whenever you are in a hurry that suddenly a utensil, metal utensil which is in your hand, it falls down. Or even in the recess in school, sometime if you bring the metal tiffin, okay, so by accidentally it must have fallen down. Okay, so you might have experienced how the sound comes from this falling down of utensil. Then second incident, we can say there was a thunderclap in the sky. Okay, so thunderclap or lightning, when the lightning with the heavy storm takes place in a sky. Okay, so what kind of sound you must have heard. Okay, just try to imagine, children. I am reading all these incidents for you. You just try to memorize, you just try to imagine that what was the sound when such incident happened. And last incident it is written is the put your hand on a speaker which is producing sound. Okay, or in any sound system is if you play the song with a high volume and try to place your hand on a speaker. Okay, what you experience. Now all these incidents, what experience they give you. Okay, let us discuss them one by one. Lesson number 18, Sound and Production of Sound, Part 2, and we were discussing about the different events and the sound which is produced during these events. Okay, you might have heard the clapping of the hands, you might have heard the any if even if you have not played any musical instrument, but you must have heard the sound of any musical instrument, let it be tabla, let it be harmonium or guitar. Okay, you might have seen how these instruments are played and what kind of sound is produced. Bursting of crackers, whenever crackers are bursted, then you might have heard that there's the with the explosion there is a production of sound. Okay, so all these 10 incidents which we have discussed earlier, it is seen from this example that in each case there is the production of particular sound. In some examples, sound was generated due to the vibration of an object. For example, you can say the if you keep a hand on a speaker, okay, you can feel the vibrations. Or if you plug the wire of any guitar, if you plug the wire of any sitar, okay, that is a musical instrument, you can feel the vibrations. What do you mean by vibration? Vibration is the speedy movements, okay, movement of an object with a high speed. Okay, if it is going moving forward and coming back, moving forward, coming back, and it happens with very high speed, then it is called as a vibration. Okay, then if you have seen or if you have touched the diaphragm of any musical instrument, you can feel the vibration. Okay, the best example is of mobile phone, which is on vibration mode. Okay, till now if you have not experienced, just put the mobile phone on vibration and give a call from other mobile number to that number and hold the mobile in a hand and try to feel the vibrations. Whatever jerk you are getting to your hands, they are nothing but the vibrations. Okay, then some examples like bursting a cracker, clapping, and then lightning strike. Here we don't feel the vibrations. Okay, when the fire crackers are bursted, we don't feel the vibrations. Means physically we are not feeling anything. However, in such cases vibrations are produced. Okay, and these vibrations are imparted to the molecule in the air. Okay, so whatever, suppose lightning, if lightning takes place, if the firecrackers are bursting, then what happened? The molecules or particles which are present in the air, they are vibrated. Okay, they are vibrations are produced among these particles and the sound is produced because of that. You might have seen that when a stone is thrown into the calm water of lake, any river or lake you visit, if it is a calm water, you try to put a stone on water. What you can see, the different waves are generated and they reach up to the bank of the lake. So the vibrations reach our ears through the through the air in a similar way, and the sound is heard. Correct? So it's a comparison can be made how the sound is produced. Whenever any sound is being produced which where actual vibrations are not experienced, then what happened? Different particles in the air, they are vibrated. Okay, and because of that the sound is produced and that reaches to our ears. Okay, so in such a way vibrations reaches to our ears. Now we have learned how the sound is generated. Okay, how the sound is generated, I repeat, in there is a presence of particular molecules or particles in the air. Okay, whenever sound vibrations are made, Okay, vibrations are imparted to these molecules. Imparted means given to this molecule in the air. Correct? The sound is heard and it reaches us on a traveling through some medium. Okay, means if someone speaks, if a firecracker bursts, whenever sound is produced, okay, it has to travel through particular medium and reach to your ear. Means vibration of an object is necessary for generation of sound. Okay, any sound which is to be heard, for that vibration is needed, and plus the sound is generated because of the vibration, and to hear that sound, to listen that sound, medium is necessary, medium is required. For example, air. Okay, we are sitting in the room where in our surrounding there is the presence of air. If you remove the total air of the room, means this room is evacuated. Okay, it's the empty. Empty means there is no presence of air. Then the two persons, even if you are sitting in front of each other and we speak, we cannot listen to each other. Okay, for example, if you keep any small piece of marble into the glass bottle, okay, and try to remove the air from that glass bottle using the vacuum pump and seal the bottle, close the bottle, then what will happen? As you have removed the air, even if you move that glass bottle with the marble inside, you cannot hear the sound. Why? Because for the transfer of sound, medium is required. Okay, so this was all about the introduction of sound. Let us try to learn the vibration, pitch, intensity and level of sound in next part of this lessons. In last video, we have discussed about the generation of sound. We have learned that sound is generated due to the vibration of an object. Let us try to understand this with the help of simple experiment. In this one, I have taken one jar. On that one, to put one cellophane paper I have taken. You can take rubber balloon as well. Then I will put one mobile which will create the sound. When we will give the ring, it will create the sounds. Okay, so I will cover the jar with the cellophane paper. Whenever you will cover the jar, we have to take care that it should fit or it should be fixed properly. Okay, means tight. It has to be tight. The surface should become tight. You can see whenever I have put this one, it has become very tight. Okay, I have stretched this cellophane paper as much as possible. Now after this, I will take some rice grains and I will put it on the surface of the jar. You can see the grains. Now from the other phone, I will give the ring to the number and let us see what happens with the rice grain. Whichever mobile we have put inside the jar, it will start ringing. You can see as the music started playing, the rice grains which are kept on the surface, they start dancing. Okay, or they start the movement. You can see it properly. Yes. As the music plays, rice grain dances. And as we switch off the music, it stops. From this experiment, what we can conclude why this happened? Because whenever we played the music, because of that sound, the air which is present inside the jar, that particles gets movement, or that they gets vibrated, and that vibration stucks on this plastic surface, and because of that vibrations, the rice grains which are kept on the surface, they moves. So with this simple experiment we can conclude that from this we can conclude that sound which is generated, okay, it is generated because of vibration, or vice versa we can say that vibration of an object is necessary for generation of sound. Now I have recorded this video to make you understand how vibrations reaches our ears. I will play one video on the screen. Just observe it very carefully. I have taken water in a bowl, and after some time, one by one, I will add small pieces or small stones from some height in the water. You can see the generation of waves, correct? After some time, again if I add some more stones, you can see the generation of waves in the water. Observe the video carefully for some seconds. Yes, you can see the waves are formed when the stone is added into the water. And this is not at all new experience. You might also have experienced this whenever you visit any particular lake and you throw a stone into the lake. The waves are generated and they reach up to the bank of the lake. Now, why this experiment I have shown it to you? I want to demonstrate it to you that vibrations which are produced of reaches our eyes through the air in a similar way. Okay, the way in which the waves are formed from the center and they reach to the bank, same way whenever the sound is produced, okay, sound is produced, vibrations are created, and that vibrations reaches to our ear through the medium of air. So this is how we have understood that sound is nothing but as the vibration of an object. Okay, when a vibration of an object takes place, the sound is generated, and same way as I have demonstrated in the video, the vibrations reaches to our ears through the air in a waves form. Thank you very much. Standard 7, Subject Science, lesson number 18, Production of Sound. In part 3, we are going to learn something more about the production of sound. In last parts, we have learned that sound is generated due to a variety of events. Okay, sound was generated due to vibration of an object, means vibration of an object is necessary for generation of sound. Now, for example, you can see on the screen different musical instruments are there. Okay, all of you, I'm sure that everyone must have seen these musical instruments, that is, let it be harmonium, let it be sitar, let it be tabla. You might have seen when a singer tunes the musical instruments, okay, any artist, when he want to play the musical instrument, he tunes the musical instruments. Means what exactly what he is doing? He ensures that sitar or tanpura, whichever he is playing, it should produce the required notes. Okay, so by adjusting the tension in strings, okay, at the end some screws are there. You can see it's a sitar, it is there, and at the top end two big size knobs you can see. On that knob, that wires are attached. There you have to ensure that this tension in string has to be tight. Then only whenever you plug the strings, proper voice or the sound which will be heard in the proper notes. Okay, even tabla player, he is having one hammer in his hand, and while tuning the tabla, he hammer the pegs sidewise. That pegs are there, that threads, what you can say, ropes are tied. Okay, he adjusts with that one. Okay, he just slightly tap that hammer on the diaphragm of the tabla. What is diaphragm? Diaphragm is the top surface. You know that white surface, and in between is circle, dark black colored circle is there. It is a diaphragm. Okay, so he adjusts the tension of the diaphragm of the tabla. Means if it is very tight, then very high note or the sound which is very sharp, that can be heard. So as per the need, he adjusts the tabla. Even the harmonium, if you see, the harmonium accompanies fine sound forehand the key in which singer will sing. Means before singing starts, he asks the singer in which note he is going to sing, and accordingly he start playing the harmonium. Okay, and you are knowing the basic notes of the music, that is sa, re, ga, ma, pa, dha, ni. These are the notes which are increasingly higher pitch. And in scientific terms, I was telling you that the measurement of the pitch is nothing but the frequency. Okay, means in which pitch that instrument is to be played, it is measured in terms of frequency. You can say that the frequency is the unit. Okay, the way you measure the length in centimeters. Okay, so the same way frequency is the measurement of pitch or sound. Now, when the string of musical instrument such as tanpura is plucked, what happens actually? You can see the strings vibrates. Strings vibrate in between two ends of the vibrating strings. Means the two ends where they are fixed, they are still, they are not moving. Only the wire which is fixed in between, that moves. As it vibrate, this means what? Vibrate means that string moves back further and backward in direction. Correct. So as it vibrates, the string moves to one side of central position and again come back to original position, and then again go back. So this motion of string is repeated again and again at fixed interval of time, and such motion is called as periodic motion. We know what is the definition of periodic motion: the motion or the movement which is carried out after definite interval of time. Means after a fixed time, that motion is occurring again and again, that movement is occurring again and again, and therefore such motion is called as periodic motion. Correct. Now sound is generated. Normally, always you have to remember, it is generated by the rhythmic vibration of an object. Means all these sounds which are created, there is a rhythm. Correct. Means we can hear the sound as long as the object vibrates. Rhythmic vibration means what? Okay, you observe the water drops which are falling from the tap. Correct. It also have one rhythm. When it is at perfect silence, try to hear that rhythm. Means after definite interval of time, it will fall down, a sound is created. Okay, so that sound is repeated and there is a rhythm in that one. Every sound which is created is having rhythm. Okay, so we can hear the sound as long as object vibrates. Till it is vibrating, we can hear the sound, and once it stopped vibration, the sound also stops. When we touch the vibrating object with our hand, the vibrations stop and we no longer hear the sound. Some or other time, if you have observed or if you have experienced the playing of sitar or guitar, you might have seen, if you struck the strings, okay, they starts vibrating, and as the moment you touch any one of the string, all the string stops vibration and the sound also stops. Sometimes we can see the vibrations, but sometimes the vibrations are so minute that we cannot see them with our eyes. Okay, sometime we can observe, sometime it is not possible. It depends on the intensity of the sound, intensity of the vibrations. Subject Science, lesson number 18, production of sound, part 4. Now, as we have learned that the sound is generated by the rhythmic vibration of an object. So such vibrations that produce sound can be studied with the help of simple oscillator. Okay, so the vibrations which produces sound, how they produce a sound, we can study it with the help of concept simple oscillator. Now what is the meaning of simple oscillator? Okay, you must have seen children playing on a swing in a garden. Okay, on a screen you can see that one swing is there, and observe, you might have observed carefully the motion of the swing. How swing works? Go to the, first of all, whenever it is at rest, correct, and when you give the push to the swing, what happened? From the starting position, first of all it goes further. After traveling particular distance, again it come back to original position, and again it goes backside. Correct? What I said, that first of all you have to go to the swing at a rest in a garden, mark its position on the ground below it. Okay, what you have to do with the swing which is constant, first of all mark the position which is the starting position. Then you can call this mark as the central position of the swing. Now pull the swing to one side and let it go. You have to pull it back and just release it, and observe how it swings. The swing will be seen to cross the central position again and again as it moves from one end to other ends of the swing. Correct? Means what? If you see the figure, right, the girl is sitting on the swing. What you have to do, you have to pull the swing to the back side, means the first picture, light shade picture, correct, it will go to that position, and once you release the swing, it will again come to the middle, then move further, again it will come back to the middle, move back. Correct? So this is the movement of a swing, and this swing that moves back and forth, that like this, is called as an oscillator. What is the concept I am trying to explain you? Oscillator. What is the meaning of oscillator? Oscillations means what? That the moving back and forth like this swing, it is a oscillator. When the swing moves from one end to other and return to its starting point, it is said to have completed one oscillation. Okay, means what? First picture, if you can see the light picture, light shaded girl's picture, from there it starts and then it come to middle, then moves further. Again it comes back to the middle and move first to first position. When this procedure takes place, we can say that one oscillation is completed. Correct? Are you getting the concept of oscillation? I repeat, when the swing moves from one end to other and return to its starting point, it is said to have completed one oscillation. Okay? And the back and forth motion of an oscillator on either side of a central position, that type of motion is called as oscillatory motion. Okay, so this was about the concept, the word oscillator and oscillatory motion. Now, with the help of this knowledge, we will try to understand, or we will try to study the different examples which are given in our textbooks. Now in this video I'm going to show how the instruments are tuned. Here we have taken one instrument, guitar. We have learned that sound is produced because of the vibrations, and here in the guitar vibration is produced because of the plucking of wires. Now in the instrument you can see the wires are fixed at both the position. Okay, the guitar bass part and here on the top portion where you can see the screws at both the end wires are fixed. And now initially you can see the wires are loose. If you pluck the wires, okay, they are very loose, and the sound which it is produced, you can hear the sound. It's very blunt sound. You can't hear the sound, proper sound of guitar. Okay, but when the strings are tightened, now using the knobs at the end, the strings can be tightened, and now if you want to hear the sound, you can see the difference when the wires are tightened, what kind of sounds are produced. Now yes, okay, so you can feel the difference, you can hear the difference when the wires were loose, what kind of sounds were produced, and now when it has been tightened, the different kinds of sounds are produced. And using this method the instruments are tuned. Okay, means here the motion of string is repeated, the motion of the wires are repeated again and again at fixed interval of time, and here the motion of these wires, they are called as the periodic motion. Why? Because the motion is been, or the motion of the wire is repeated after definite interval of time. Standard 7 Science, lesson number 18, Production of Sound, part 5. After learning the concept of oscillator, oscillations and oscillatory motion, let us try to understand the different examples of this oscillation. First example you have to do is take an empty porcelain bowl or empty steel glass. Stretch a rubber band and fix it on the bowl or glass as shown in the picture. Okay, in the picture you can see one glass bowl is been taken, and on that a rubber band is stretched and fixed. Now what you have to do? Give a jerk to a rubber band. Okay, little bit you have to pluck the rubber band, and then repeat this action after applying a smaller or greater force. While doing this, observe the farthest distance to which the rubber band is stretched and take a note of the sound generated. Means you have to stretch the rubber, you have to plug the rubber with the different distances. Initially with a small distance you try to stretch the rubber. Then try to maximize the stretching of rubber and release it. Okay, you can hear the particular sound, and every time you will realize you can hear the different kinds of sounds. Now what happened? When the rubber band is stretched and released, it vibrates, it moves from up and down, or it oscillates. Now compare the vibration with the figure or the which we have studied in the previous example of the swing. Same way, suppose if this is a oscillatory or this is a swing, okay, what you have to do? You have to, when the rubber band is stretched from the original position, it will be A, correct? And then it comes to the position B, you have to stretch it up and it is seen to be curved. And the maximum distance between the original position A and position B on a stretched rubber is called as amplitude. Okay, you can see the figure, it is shown in the figure. To the fixed point O, one string is been tied, and to that string one metal ball is been hanged. Okay, now in that one you can see if in the starting position if it is A, and when it is stretched from this A to B, okay, Then you can see the curve, dotted line, A to B, dotted line you can see, and then it is maximum distance between that point A and point B. That is called as amplitude. That distance, curve distance, is called as amplitude. Okay. Now, when a greater force is applied to a rubber, what happened? It stretched further, meaning that amplitude increases. And on releasing it, a louder sound is generated. When a smaller force is applied, the rubber is stretched less, and then the amplitude is smaller and sound is also softer. So, this kind of example gives us an idea how the oscillation moves, what is the meaning of amplitude, and if you apply the greater force, what kind of sound is produced, and if we apply the smaller force, what kind of sound is produced. We can try this experiment at home as well. Lesson number 18, sound, that is production of sound, part 6. Having learned the concept of oscillation, oscillatory motion and oscillator, let us try to understand the concept time period of oscillation and frequency. Okay, what is the meaning of time period of oscillation and frequency? To understand this, we have to carry out one experiment, one small demo. As you can see on the screen, one strong thread is being taken. What we have to do? Take a strong thread about a half meter long, and to that end of that thread tie one small iron or one small wooden ball, and that we have to tie to particular support. Any solid support you have to fix or tie that thread. Now what will happen? As you can see in the position A, okay, that string will be hanging from the support, means in a straight direction it will hang. Okay. Such oscillator is called as pendulum. Okay, are you getting that word? What, see, these are the physics concepts and we are learning them as a new one. So what I'm trying to explain is the concept called pendulum. What is that? To one thread, another you have to tie one wooden ball or metal ball, and another end you have to suspend it to one support, and such oscillator, this oscillator is called as what? Pendulum. Okay, now give an oscillatory motion to the pendulum, and the maximum distance between the original position A of pendulum and the extreme position B or C is called amplitude of the oscillation. And in the figure, AB or AC is the amplitude of oscillation. Means if you start from the point A, okay, and give the jerk, or you can just, if you stretch the pendulum back position in this position till position C, then this distance is called as the amplitude. So the distance between A and B or distance between A and C, we call it as a amplitude of oscillation. See, these are some new concept, and with respect to physics you are supposed to know this word. So I am emphasizing on this word again and again. Pendulum word I emphasize. The next word I used is the amplitude of oscillation. Okay, so you understood both of these concepts. This one is called as pendulum, and amplitude is what? The distance between A and B or distance between A and C, that curved distance. So children, you just see, you know that if you give the tap to the pendulum, it will move in a curve. Okay, up and down, it is going back and forth in a curved direction, not a straight direction. So that curved distance between A and B or curved distance between A and C is called as the amplitude. Okay, amplitude of oscillation. Now, next part that we are going to learn is time period of oscillation and frequency. Now, what is the time period? Okay, this concept we are going to learn is time period. What is the time period? The time required by an oscillator to complete one oscillation. It's called the time period of the oscillator. Okay, so what is the time period? Time period means, again, suppose if I go back and I want to try to show you this one. Okay, if the pendulum starts from A, it will go to B, again it will come from B to A, then A to C, then one whole rotation, that full complete round is called as one oscillation, and the time period required by this or to complete this one oscillation is called as the time period of oscillator. In the previous activity, oscillator traversed the distance from the extreme position B to central A and from there to position C, then back again to A and from A to B. So this process continues. Okay. So the time required by the oscillator to traverse this distance, okay, B to A to C, C to A, and again A to B. This is the time period of oscillation or T of the oscillator. Okay, it is shown by which letter? Capital T. The number of oscillations completed by an oscillator in 1 second is called as the frequency of the oscillation. Okay, so one more word, two concepts we have learned over here, that is the time period. What I am trying to explain you, time period and frequency. What is time period? The time required by oscillator to complete one oscillation is called time period of the oscillator, and the number of oscillations completed by oscillator in 1 second is called the frequency of the oscillation. Now, this motion that B to B A C A B is in the previous activity is one oscillation. Now, how to find out the frequency? Frequency formula is what? It is denoted by small letter n, and it is 1 upon time period of oscillation, that is T. So, the formula for this is what? 1 upon T. Formula for frequency is what? 1 upon T, where T is the time period. Okay, and frequency, what is a frequency? Then we can say is the number of oscillation occurring in 1 second, and the unit of frequency, the way we have the units to measure the distance, measure the temperature, measure the weight, we have the unit to measure the frequency, which is called as hertz. See children, all these words which I am underlining or which I am repeating again and again, they are very important from the point of physics. In physics, all these terms you are supposed to know. Correct? So, frequency is nothing but the number of oscillations occurring in 1 second. Unit of frequency is hertz, and 1 hertz means there is 1 oscillation in 1 second. And 100 hertz means 100 oscillation in 1 second, means per second. Whatever answer you will get, it is per second. So this was all about the time period of oscillation and frequency. Standard 7th in science subject, we are learning lesson number 18, sound, production of sound. In part 7, we are going to learn certain different concepts which are related to the concept sound. Now, in previous videos, we have seen the different experiments. Okay, in experiment in which one elastic rubber was stretched over a porcelain bowl. Now, some concepts you are supposed to know, that a stretched rubber which returns to its original state when it is released, then that property is called as elasticity. Okay, so you might have heard this word elastic. Okay, means instead of rubber, some people call it as a elastic as well. But from where that elastic word came? that property of elasticity. What is that property? When a rubber is stretched, okay, it can be stretched up to particular extent, but once you released it, it returned to its original state, and that property is called as elasticity. When a stretched rubber band vibrates, elasticity is at work. Means whenever we are plucking the rubber and it is vibrating, then we can say that work is being conducted. Okay, and all the while that pendulum oscillates, Earth's gravitation is at work. Means in every concept, in everywhere, somewhere the work is being done. Correct? Every aspect, the work done will be different, but work will be definitely done. How? When stretched rubber band vibrates, the work done by elasticity or by rubber, or when the pendulum is oscillating, then Earth's gravitational force is at work. Okay, or on the pendulum or on the swing, gravitational force is working. So these are certain physical concepts we are supposed to know. Now next concept or next experiment we are going to learn, as you can see on the screen, one ruler you have to take. Okay, and first of all you have to hold one of the end of the ruler and press down on the table. Means you have to, with one hand you have to keep the ruler on the table, and by one hand you have to press it, and by another hand we have to stretch, or we have to move that metal scale, ruler or scale. Okay, so what I have told you, let me repeat. You have to take a plastic ruler or metal ruler and hold one of its end, press down on the table as shown in the picture. Okay, so why? Because so that a large portion of the ruler is off the table. Means a small portion should be on the table and large portion should be out of the table. Now observe what happened when you press the ruler with your finger. Okay, when the distance between that scale which is outside the table is more, what happened you have to observe. Obviously, suppose initially if that distance is of 11 centimeter, okay, then you have to count the vibration, or you can hear the sound. Then count the number of vibrations. Okay, next step is what? You have to little bit shift the scale inside so that the outside portion will be less distance, and again try to listen the difference of the sound of the second one for the first one. Then you have to go on decreasing the distance and try to listen the sound as well as try to count the vibrations. Okay, and from that what we can conclude. Now will a sound which will be generated, how the how the ruler is kept on the table. Means if the distance between the hand and ruler is more, the sound will be more, but as you go on decreasing the distance, will the sound will be produced? Yes, obviously sound will be produced, because there will be some or less vibration will be there. But there is a correlation between the length of the free part of the ruler and the sound generated. Means more is the free part, sound generated will be more. Okay, and if the ruler is plucked when it is held with some more distance of the table, does it make any sounds? And if there is no sound, what is the reason? Means if you are holding for a very small distance, okay, you are holding a scale outside the table by very small distance, then what happens? So from this we can conclude, when the distance is more, length of the free part is more, the vibration will be more, vibration of the scale will be more, sound will be generated. When as you go on decreasing the distance, the sound sound of the ruler also decreases, because the vibration will be less. Okay, so this is the small experiment given. We can see that experiment. You can perform this experiment at home as well. Okay, Standard 7 Subject Science, lesson number 18, Production of Sound, part 8. Proceeding in this lesson, we are going to learn one experiment. You have to take one pendulum. What is a pendulum? Pendulum is an oscillator which is made up of a small iron or wooden ball which is tied to a half-meter long strong thread. Okay, either you take half meter or any sufficient length you can take, and other end of the thread is tied to a fixed support. Correct? So what you are supposed to do, take a strong thread of a sufficient length and tie a wooden or metal bob to one of its end to make a pendulum. Measure the length of the thread in centimeters and make a note of it. As you can see, it is given in the table. You have to make one table. First of all, what you have to note down, you have to measure the length of the oscillator, length of the pendulum. Correct? Then suspend the pendulum freely from a support. That pendulum you have to fix to that one position and then give a jerk, or you can say suspend initially to a support and then swing the pendulum, and with the help of stopwatch, you have to keep ready one stopwatch or any watch which can count the oscillations. Okay, with the help of stopwatch, record how many seconds are required for 20 oscillations. Means first you have to count or measure the length of the oscillator, then for 20 oscillation how much time is required, that you have to note down. Then repeat this procedure for 4 to 5 times. How? By decreasing the length of pendulum by 10 centimeters every time. Means initially if the length you have taken is of 50 centimeters, then next will be 40 centimeters, to that next will be 30, and then next will be 20 centimeters. Means every time you have to decrease the length of oscillator, length of the thread, and you have to see the time required for 20 oscillations. You have to count that time. Correct? After taking 4 to 5 records or observations, fill that into the table and find out the time period of oscillation. Okay, as you can see in the table, they have given us table. Here what you have to do, suppose initially the length is 50. Initially the length is 50, then and time required for 20 oscillation t in seconds is 50 seconds. This randomly I am taking. Okay, for 50. So how you will count the time period of oscillation? That is t upon 20. So t is our 50 upon 20. Correct? Then 0 will be cut and this value will be 2.5. And frequency, how you have to find out? Frequency is not again 1 upon t, means 1 upon 2.5. Then find out the value. What value you will get here? 10 upon 25. Then 100 upon, you will get 250. So you have to count, write down the answer in decimal points. Every time you have to note down such values. Correct? Means what I am trying to tell you, first if you take the 50 centimeter, then time required, and then find out the t, find out the hertz frequency. Next, suppose if you take 40, how much t will be required, that you have to find out, and then go on finding the further values. Now when you complete this table, what observation you make? Okay, we have to observe, we have to conclude from this observation, or what is the relationship between the frequency and length of the pendulum. Okay, so what we can say, as the length of the pendulum decreases, when we go on decreasing the length, the time required also will be less. The time period also decreases. If time period decreases, then of course the frequency also will decrease. Correct? So that is the relationship between the length of the oscillator, length of the pendulum and the frequency. We can say the frequency of oscillation changes according to change in the length of pendulum, and frequency decreases on increasing the length of pendulum. Means there is a inverse proportion. Frequency, if length is increased, frequency decreases, and if length is increased, frequency decrease. Okay, so it is a inverse proportion, opposite proportion. Okay, so this was the one of the experiment that we have to conduct in this lesson, but as due to corona we cannot go into laboratory, so I am trying to explain it to you on the screen. Try to understand, and if we get a chance we will perform this experiment. I can show you the experiment on the screen only. I will continue that experiment in the lab or at home, and I will send a video for it. Standard 7 Science subject, lesson number 18, Sound, Production of Sound, part 9. In this part, we are going to learn one more experiment, one table you can see on the screen. Actually, now we can't perform the experiment due to this corona or pandemic situation. We can't perform it in the lab. I can't show you, but with the help of table, I will try to make you understand what does this experiment means. In previous experiment, what we have done, we have changed the length of oscillator. Okay, what I told you initially, you have to take 50, then 40, then 30, means you have to go on decreasing the length. In this experiment, what they have given, you can see that the length of pendulum you have to keep constant. Okay, it will not change. Everywhere the length of pendulum will be 30 centimeter. Then what will be changed? Here the amplitude will be changed. What is amplitude? Amplitude is the distance between the starting point to the end point, okay, of the pendulum. That is called one amplitude, means from initial position to final. Okay, that one movement is called as the oscillation. For example, I gave you the example of A to B, B to C. So, distance between A and B and distance between A and C. Individually it is called as amplitude. So, what you have to do? You have to keep the pendulum length 30 common, and you have to go on changing amplitude. Means what? First of all, you have to give the little bit jerk, means it will be small movement. Then count the time required for that, 20 oscillation. Okay, then little bit more jerk, then larger, then even larger, and then even large, very large. So every time you have to count the time required for 20 oscillations and note down in the table, and find out the time period, okay, and find out the frequency. Okay, now once you complete this experiment, what you can find, what we can conclude from this, that the time period of oscillation, that is T, depends on the length of the pendulum. The time period of oscillation increases if length pendulum is increased, and frequency remains same even the amplitude increases or decreases. Okay, frequency remains same everywhere. Frequency will be same even if you increase the amplitude or decrease the amplitude. I am talking about this red colored. See, I am circling it again and again. Even if you increase or decrease the amplitude, frequency is same. I will try to write it again. Frequency remains same even if the amplitude increases or decreases. So from this experiment, we can, both the experiments, these experiments and in previous part, one experiment we have learned, from this we can conclude the thing. Okay, initially what was that? The frequency of oscillation changes according to change in the length of oscillator, and there is inverse proportion. And second experiment, we have seen that frequency remains same even if amplitude increases or amplitude decreases. Okay, so here we have completed the explanation for two experiments. Lesson number 18, Sound, Production of Sound, Part 10. In this one, we are going to learn the high and low pitch of sound. To understand this, we are going to see one instrument, you can say, or one diagram as shown on the screen, with which is made up of one wooden board. First, let us understand what is that arrangement. For that, you have to take one wooden board which will be 80 to 90 centimeters long and 5 centimeters wide. Then hammer two nails into it, one each a few centimeters away from its wire, from its two ends. Means you can see on the screen, if I want to mark you, two screws you have to fix. These are two screws. Okay, you have to fix onto the board. Then tie the ends of the thin metal wire to the nails so that wire is stretched tightly between them, and insert a wedge shaped wooden or plastic block under the wire near each of the nail. Means you can see this is the wire, long wire, and that is stretched, that is tied between these two ends, and it is stretched and tied. You might have seen the video which I have shown, that is the tuning of guitar. Okay, to make you understand the pitch of the guitar. There was also the same case. At both the ends, the wires were fixed with the tension in that one. Okay, it has to be stretched enough so that proper voice should come out from the guitar. Same way here, for the two nails, these two nails, a wire is stretched in between, and in between that one wooden block or wedge is been pressed or kept. Okay, now what you have to do? Plug the wire. Okay, you have to plug the wire. Did you hear any sound? Observe whether the wire vibrates. Now insert 2 or 3 small rectangular blocks below the wedge shaped block. Means you have to increase. Initially this wooden block, which is only this part, upper part will be there. Below that you have to keep 1 or 2 more extra blocks, and observe whether there is any change in the tension in the wire. Okay, so can you guess, children? If you increase this number of blocks, what will happen to the tension in the wire? Yes, obviously it will be stretched more. There will be more tension in the wire. And now if you plug the wire with your finger and try to listen the sound, see the vibration, and you can see there is the difference which you perceive in its frequency. So from this, what you can infer? When tension in the wire is increased, the frequency is seen to increase. When tension is increased, frequency is seen to increase, and when the frequency, when the tension is decreased, the frequency also decreases. So we can see the difference in the sounds generated also. When tension is increased, the resulting sound is shriller. Shrill sound means a very sharp sound, you can say. And when the tension is reduced, the sound is less shrill. Okay, if you want, you can just go through the video in which the plucking of guitar I have shown. When the wire is very loose, you can hear the blunt sound, that it is not at all shrill. But when the wire is tightened, and if you plug the wire, the voice which is coming is very sharp voice, shrilled voice. Okay, so this is what is called as the pitch of the sound, high pitch and low pitch of the sound. If sound is more shrilled, more sharp, then we call it as a high pitch sound, and if it is less shrill, then we call it as a low pitch of sound. What is that word pitch? The spelling is PITCH, that is called as the pitch, and the concept is what? High pitch and low pitch of sound. Lesson number 18, Sound, Production of Sound, Part 11. In this part, we are going to learn the concept intensity of sound and sound level. In our day-to-day life, during any activities or whenever you are on a playground, if someone is shouting too loudly, then we get irritated. Okay, if someone is sitting next to you and shouting and talking or laughing loudly, then you can't just bear it. So what you have to tell them, that please be quiet, or you please be talk in a low volume, because you are hurting our ears. Correct? Means in our day-to-day life we only have two concepts, that is speaking loudly or loud or very low volume. Now to measure the sound, to measure the intensity of sound, there are particular units, there are particular units or the concepts which are used to measure the intensity of sound. Means even if it is said it is loud, okay, suppose one child which is playing on the playground, his voice when he is talking or he is shouting, we just say your voice is very loud, you are shouting. And even if someone is playing music using the speaker with very high volume, that also we call it as a loud. Means both the voices, if they are loud, which one is more louder? To measure that concept, to understand that concept, we are going to learn today's concept, that is intensity of sound and sound level. Now, loudness or softness of sound is indicated by these two terms, that are intensity of sound and sound level. Sound level is the intensity of sound as perceived by our ears. The intensity of sound is proportional to the square of the amplitude of vibration. Means if the amplitude, if you double the amplitude, the intensity of sound becomes 4 times as much. Okay, means you can see the relationship between the intensity of sound and amplitude of vibration. Now the next concept that we are going to learn is the unit that is called as the decibel. Okay, you can see how to write the short form for the decibel. Small d and capital B is accustomed to write the unit of the decibel. The decibel is the unit for measuring sound level, and it was named decibel in honor of the work of the scientist Alexander Graham Bell. The magnitude of sound level, decibels, can be deduced from the intensity of the sound using mathematical formula. When intensity of sound becomes 10 times the original, the sound level increases by 10 decibels. Okay, means what is the correlationship? What is the correlationship? How it is? See what they are telling, how to find it out. Intensity of sound become 10 times of the original. Means the way, suppose I am speaking, then the intensity, if the intensity of sound become 10 times, means if I shout 10 times more, then the sound level will be increased by 10 GB. It is not 10 times by number, it increases by number 10 decibels. Okay, so that is the relationship for the calculation of the sound level. At this level you don't have to calculate, you just have to remember the unit for measuring sound level is the decibel, or intensity of sound can be expressed by unit decibel. Okay, so here we have next part, we are going to learn the decibel levels of some common sound, the sounds which we hear in our day-to-day life. Science subjects, lesson number 18, production of sound, part 12. In this one we are going to learn the decibel levels of some common sounds that we hear in our day-to-day life. First one, beginning of audible sound starts with the 0 decibel. Okay, means the sound which is audible to us is called starts from the level 0 decibel. And then next, normal breathing. Okay, it is how much, what is the sound level of it? 10 decibels. Murmuring from 5 meters away means if any person who is 5 meters away from you and whatever he is speaking, and still if you are able to hear it, then its sound level will be 30 decibels. Then normal conversation between two persons. Okay, murmuring means whispering in a low volume, but a normal conversation, whenever two persons are talking, the sound level is 60 decibels. Then heavy traffic, where continuous the vehicles are giving horns or running with their noises, then the traffic is having sound level 70 decibels. Ordinary factories, they are having sound level up to 80 decibels. Jet engine, jet engine you might have seen or hear, even if it is flying in the sky, still you can hear the sound, means that the intensity of sound, see how much high it might be. Okay, what is the value for it? It's 130 decibels. Start of ear splitting sound means the sound which you cannot hear, then it is how much it is? Sound level is 120 decibel. Means if it is sound level is 120 decibel, you cannot hear the sound, you just want to close your ears, or you want to go away or run away from that place. That is called as the ear splitting sound. It is how much? 120 decibels. Then hearing is temporarily affected by sounds of frequency greater than 1000 Hz and levels higher than 100 decibels. This can result in temporary deafness, and workers who work near aeroplane engine must have experienced this one, because aeroplane engine, as I told you, even if it is flying high in the sky and we are on the ground, we can experience the sound of the aeroplane. Then you can imagine the person who are workers or people who are working near the aeroplane engines might be experienced continuously or daily. They have to hear the sound which is crossing the 120 or 100 decibels. So in such people, the temporary deafness means the losing power of or hearing power. Okay, the temporary deafness is observed in such people. It can be cured, but it takes time. Means continuously or permanently they don't become a deaf, but that deformity is been seen in the people who are working near aeroplane engines. Standard 7 Subject Science, lesson number 18, Sound, Production of Sound, part 13. What would be the difference perceived between the hearing only two pupils in the class talking to each other and all the children talking to one another at the same time? Correct? These are the questions which they have asked in the starting of this topic. Okay, so let me tell you that in this part, in this topic, we are going to learn the topic audible sound, infrasonic sound and ultrasonic sounds. Means the sounds which we can hear. There are certain sounds which we cannot hear, means the human being don't have the capacity to listen that sounds. So what such sounds are called as? All these things we are going to discuss. Now we can hear, or we can just experience that when only two children are talking, we can hear the sound very clearly and we can understand it in a proper way. But when full class is talking, all are screaming at a time, then we cannot exactly identify whose sound is what and who is talking what. Correct? Then first concept which we are going to learn is audible sound. Now whichever the two children they are talking among themselves or the many they are talking at all, that sound, if it is between 20 hertz, its frequency is between 20 hertz to 20,000 hertz, then such frequency is called as, such sound is called as audible sound. And a human being can only hear sounds which is this frequency range, that is 20 hertz to 20,000 hertz. If this is the frequency of the sound, then only we can hear. Then what do you mean by infrasonic sounds then? Infrasonic sounds means the sounds which have the frequency less than 20 hertz. Okay, a human being have the capacity to hear the sound which is from 20 hertz. If the sound frequency is less than 20 hertz, then such sounds are called as infrasonic sounds. You might have seen, or you might have just seen, that the movement of our hands means if you move the hands you cannot hear the sound, but if you move your hand very vigorously, then little bit sound you can hear. Now why is this so? Because when you move hands slowly, the frequency of the sound is less than 20, so you cannot hear. But if you move your hand, shake your hand vigorously, then little bit sound you can hear, because the frequency crosses 20, it goes above 20, then you can hear the sound, correct? So what are the infrasonic sounds? The sound which have the frequency less than 20 hertz, correct? And next concept that we are going to learn is ultrasonic sound. A sound with a frequency higher than 20,000 hertz is called as ultrasonic sounds. A human beings cannot hear such sounds also, because above 20,000 hertz our ear don't have the capacity to hear, to catch that frequencies. But some animals like a dog can hear such sounds. Okay, you might have seen that if there any earthquake or something is going to happen, these animals can sense it immediately. Why? Because they have the capacity to catch the frequency, to listen the frequencies which are above 20,000. Okay, so such dogs can hear ultrasonic sounds, whereas a sound with a frequency less than 20 hertz, okay, they are produced by some animals like whales, elephants and rhinoceros. Means the elephants, we think that elephants are so quiet and calm, they are not talking, means like other animals, they are not making any normal sounds, but they talk, but only thing is that we cannot hear, because whatever sounds waves they are produced by the elephants, they are less than 20 hertz, and therefore we cannot hear the sounds which are produced by elephants. So such sounds less than 20 hertz called as infrasonic sounds, more than 20,000 hertz they are called as ultrasonic sounds, and the sounds which are between 20 to 20,000 hertz they are audible sounds. So in this way sounds are categorized according to or based on the frequency level. You can see one diagram is given in your book. Okay, from that you can see the pitch of sound. Also you can conclude something, that the pitch of sound is directly related to the frequency of sound. From the graph we can just get the information that the frequency of sound and infrasonic, audible and ultrasonic sounds. Okay, you can see in the graph on x-axis they have plotted frequency of sound, and on y-axis they have plotted different animals. Okay, you can see infrasonic range, a blue whale, it can hear the infrasonic sound. The violin, flute, it is audible to human being, whereas the frequencies above 20,000 hertz, you can see they have given dolphin, bat, they can sense the ultrasonic sounds. Okay, so this was the introduction about the frequencies, and based on that frequency the sounds are categorized. Lesson number 18, Sound, Production of Sound, Part 14. This is the last part of this lesson. In this part we are going to discuss the uses of ultrasonic sounds. In the previous part we have discussed that which are the ultrasonic sounds. A sound with a frequency higher than 20,000 Hz is called ultrasonic sound, and human beings cannot hear such sounds. However, some animals like a dog can hear such sounds. Okay, so what are the different uses of ultrasonic sound? Let us see it one by one. First one, to clean the delicate ornaments and the tiny parts of a watch, ultrasonic sounds can be used. Okay, that means if the ornaments which are having very small and delicate diamonds or the tiny parts of watch, that can be used by ultrasonic sound, it can be cleaned by that one. Okay, next one, to observe the internal organs of the body, also the internal ultrasonic sound can be used. Then to detect the tumors in the brain, this type of sounds, ultrasonic sounds can be used. Then to detect the faults in a metal, if it is a very any company in which different metal sheets are made, then if any crack is there in between the metal rod or metal sheets, it can be detected by using ultrasonic sound. Then in radar systems also ultrasonic sound system is fixed. Okay, what is this radar system? Radar system is something that is a safety or the system which is used by defense mechanism. It gives you the idea about the any enemy, either it is attacking or it is doing any unwanted activity beyond the border. So radar system gives the idea by using the ultrasonic sound waves it can be detected. Then to kill certain microbes and insects also, so these ultrasonic sounds are used. One more use for this is sound navigation and ranging system, that is sonar, is used to locate the seabed or the position of a ship. Means if you want to see all these uses in detail, the different material is available on the Google. Okay, you can go through this because each part whichever discussed in these uses is in detail, it is very vast topic. Okay, so we cannot discuss all these things in a detail over here, but just try to remember that the ultrasonic sounds, they are very much useful in the important things. Okay, they are all the things, if you see, they are all related to health, related to safety, related to economically also it is very useful. Therefore uses are very important. Ultrasonic sound are very important. If you want to learn them in a detail, you can just go on the internet and find out the topics or find out these uses and try to learn them in a detail for your extra knowledge. So here we are ending the 18th lesson, that is sound and production of sound. In this lesson we have learned a different physical concepts, that is motion, periodic motion, oscillatory motion. Then we have learned the physical concepts like amplitude. Then we have learned the frequency, time period. Okay, so these different kinds we have learned. Then we have understood the high and low pitch of sound. Then intensity of sound we have learned. Then different categories based on frequency, that is audible sound, infrasonic sound, ultrasonic sound we have learned, and we have also discussed the uses of ultrasonic sound. So here we come to an end of the lesson number 18, that is sound, production of sound. Thank you very much.